What's good, class, and welcome to another edition of Mr. Fitzgerald's biology class. Today we have actually something cool that's going to happen. At least I hope it's cool, depending on how well I edit this video. But we're going to investigate some different properties of water through a little bit of a demonstration. So instead of actually you being hands-on throughout the whole process in the classroom, we're going to do a digital version and see how well that goes. But if you want to follow along at home, I'll tell you what supplies I'm using and what you could probably find in your house to do something similar, so that way you can kind of see these things in person and get a little bit deeper with it as well. So really what I want to start off with is kind of just a thought-provoking question, okay? So looking at this picture here, and the definition might not be great for you, but there is a spider on top of this puddle of water. And the question is, why is this spider able to walk on water? So clearly I do see the spider on top of the water. I do see that it probably has the ability to move and progress itself along the water without sinking, but why is it able to do that, but I am not? If I tried to stand on that same puddle, I would probably go right to the bottom very quickly. So what advantage does it have over me in terms of water? So obviously the spider is smaller than me, probably has less weight and mass, but why is the water allowing it to do this and not say somebody like me? All right, so what we're going to do is actually 3 experiments today to kind of describe the different properties of water, or give us all a visual foundation that we can build our vocabulary on. So the 3 experiments we're going to do first is we're going to see how many paper clips we can float on the water's surface. Okay? Then we're going to see how many drops of water I can put on the surface of a penny. And then finally, we're going to dip a paper towel and actually observe what's happening to the water in the paper towel over time. Okay, so if you wanted to do this at home, all you're going to need is a glass of water or a cup of water. Because it's a science classroom, I have access to beakers, so I'm going to use a nice little beaker, but any cup will do. I suggest one that's kind of clear and a little rounded at the top and give you enough space to work your hands in there as well. Also, you'll need a bunch of these paper clips. I'll give you a trick on how to get them to actually float throughout this activity, so that way you're able to do it the best way possible. You will also need a penny if you have one, if you are able to do the drops on a penny, and you'll need some sort of dropper. Now, not everybody's going to have this in a house. It's a very, odd thing to have laying around, but if you did have a dropper or something that could work as one, maybe you can try it out as well. But I'm assuming everybody has a paper towel, or at least a napkin or a sheet of paper. So this one you could do if you'd like, where you just need a glass of water and a paper towel to actually explore it. So, with all that being said, let's zoom into our experiments. Whoa.
Now the first experiment I'm going to start with is the paperclip float. Wanted to start with this side view so that way you can see what's happening at the surface of the water. Now, a lot of students will try to float their paper clips by just kind of placing them in like so when using their fingers, but actually it makes it a lot difficult to get this experiment done well. So what I've done is I've kind of modified a paper clip. So how I'm going to do that is I'm going to take a regular paper clip, I'm going to kind of fold it to extend it outward and make what looks like kind of like a soup ladle. So that way I can balance paper clips on it and kind of lower them in slowly, and then use this tool to kind of help me, instead of my fat little fingers getting in there and messing up the water. All right, so we're gonna see how many I can float up there. I have paper clips off here to the side. I got a box in case I need more. See how good I am. And let's see how many I can get to float. All right, first paper clip, wish me luck here. All right, first one is in. Have a lot of room here. Uh-oh. So right now the paper clips are working against me. They've made a nice little pack in the middle. See if I can fit one more in here without disturbing it. Excellent. All right. Hopefully by now you kind of started to notice the paper clips seem to be kind of sinking and making an impression in the water. I'm going to try to move this mass around a little bit so you can kind of see that from the side view here. So you can kind of see that they're dipping below that water level line, but it almost looks like that water level is just kind of pushing up against them. And in the corners, you can actually see kind of a little bit of an edge that's forming. So I'm going to keep going until I can't anymore. All right, so right now I'm at 8. The problem I'm having is they're not giving me much room. I will show you an over top view of this as well, so that way you can kind of get a look at what I'm seeing here. All right. So on the top view, if you notice, all these paper clips are starting to kind of come together. Even if I push them apart a little bit, they're still wanting to kind of stay together in a big clump. So you can kind of imagine the water's kind of dipping down like a little bowl. And if I try to get one out of the way, right, the whole bowl follows. Fortunately, I just knocked one in there. So if you're doing this at home, you can keep repeating until basically you get one to fall. All right, I'm gonna stop here because you kind of get the concept that I want you to see, that dip down that's happening right here at the water level as the weight of the paper clips push on it. And it looks like from the top as well that you can see, there looks like there's little bubbles, right, around surrounding the paper clip where the water's kind of pressing through in the center areas and is making it kind of a little bit risen there as well. This next experiment is called Drops on a Penny, and it is exactly what you think it is. I'm going to try to put as many drops of water on the penny as I can. So I have my standard penny here. I have a little dropper. You might not have this at home, so you might not be able to do this on your own. That's totally fine. But really what's important is making the observations with everything that we're seeing today. So I'm going to just basically be adding water slowly as full droplets in order to see how much I can get on there. Okay, so we'll start off with our first drop, second, and as you notice, it's kind of beating up in the center here. Third, fourth, fifth, sixth, seventh, eighth, and it looks like it's slowly starting to spread out. A little nice little air bubble pop there a little bit, but it's starting to slowly spread out and it wants to kind of stay together. $27. All right, I'm going to take a moment here to take you kind of to the side view of the penny. All right, now we're at the side view of the penny, and you can really see it's making kind of like a dome shape on the top. And it's starting to try to come towards the edges a little bit. Now, the penny does have a design where it actually has a little raised up edge. So I'm going to keep adding water, and notice how it kind of bounces around as it comes in. I'm going to see if I can get it to actually overflow the edge without spilling. Now again, look how that bubble has really taken a full mass on top of the penny. It's still just reaching the edges now on all sides. The front side, you can't really see it too well. I'll try to adjust a little bit for you, but the focus can't really gain it. The front side is starting to kind of spill over the edge. It's actually bubbling over where the water is actually not in contact with the penny anymore. It's actually being suspended in the air. So it's only being held by the water that is currently on the penny. And as I continue, you can now see it kind of curl up and make that impressive like little balloon kind of shape over top. I'm gonna try to keep going, see if I can push the limits here. And now it spills over. But even as it spills over, notice how that water is still kind of oozing out together as one unit. Right, and it's trying to stay together through this whole thing as it moves off the surface of the penny and starts onto the surface of the table. All right, now the last experiment I'm gonna do with this water properties is called the paper towel dip, and it is exactly what it sounds like. I'm gonna take this paper towel and I'm gonna dip it into the beaker of water. We're gonna observe the changes that are happening with the paper towel more so than the water. So let's kind of dip it in. All right. And if you notice very quickly, all right, it might be hard to see with the contrast, but the water seems to be kind of being absorbed by the paper towel. It's getting soggy at the bottom. But more interestingly, the water level is here. However, right now on the paper towel, I'm getting water all the way up at the top of the glass. So really, water is able to kind of move up this paper towel because the paper towel has these little thin grooves in it. And so it's kind of like little tubes, just like when you're at a restaurant and you're drinking out of a straw, and you notice how the water level in the straw is a little bit higher than the water level in the cup. So that property is called capillary action, how water will actually move up tubes, and it's why paper towels are so efficient at picking up water when we spill it, because it uses all these little tubes inside the paper towel to give areas for water to kind of crawl into.
Whoa, to zoom out. Ooh, that's always the hardest part there. Hopefully you saw some interesting things and you were able to record your observations on your lab sheet as we went along. But I wanted to bring this picture back up, blown up a little bit more so that way you can see the finer details and kind of relate it to what we've already investigated today. So again, I still have my same spider on the same puddle of water, and you might be able to see the finer detail now where it kind of looks like each leg is making an impression. Just like how those paper clips were making a nice impression into the surface of the water, and you kind of combed around or made like an inverse dome around the paper clip. The spider's legs are experiencing the same thing. So it looks like the spider has that same ability as the paper clip, but why isn't the water just spreading out, right? And just kind of moving away from the spider or the paper clips? Well, the drops on the penny kind of show us that water wants to kind of hold together. Specifically when that penny started to ooze out and the water was kind of dripping off and kind of moving as one unison group, it was trying to stay together instead of spread itself apart. Even though it was getting more surface area to spread, it was actually still moving as a collective unit in one direction. So hopefully these experiments give you a little bit more of an insight into water and some of its properties, in particular when we talk about the vocabulary that goes along with it. There's a lot of new science words you probably haven't heard before, so having this experience with me will probably help you visualize it as we're talking about it. This is Mr. Fitz signing off, and stay curious.